Start recording. Good. Okay. Okay. Jetzt wir haben angefangen mit der Recording. Ich will vermachen hier.
Hey.
Als wel soll uns nicht stören. Verstehst? Keiner soll uns nicht stören. Und jetzt. Okay, sorry. Yeah. Okay. So now I want to talk to you. Okay, we did the exponents, right? 2 weeks ago?
Yeah.
Okay. So.
You didn't come last week.
Because the letzte Woche hast du gegangen ins Camp Ramah, ja? Hast du gegangen für Shabbaton. Okay. So now, I want to do some things. The first thing I want to talk about is how do humans learn new things? There's actually, two ways, right?
Mm-hmm.
One way is humans learn empirically.
By noticing things.
Huh?
That means by noticing things, right?
By noticing things, yes. I'll write the word here and let's see if you know how to read English.
Empirically. By noticing things, by observing.
Yeah. Okay. And the second way that people learn things is by somebody telling them. Okay, so knowledge is learned either in two ways, okay? Knowledge is learned in two ways. I know it's hard for you, it's not always easy for you to read.
Empirically.
Yes. The first letter is the way I write an R.
I know that's an R.
Yeah, that's an R.
I know.
Okay.
Revelation.
Yeah. So knowledge, either you learn it yourself empirically, right? Or number two, it's revealed to you. Do you know what revealed means?
Yeah.
Okay. Now it's revealed either by der Eibishter, okay, or it's revealed to you by other people.
Mm-hmm.
Now, when it's revealed to you by other people, you have to be very, very careful, because you can't trust what other people tell you 100%. You understand? Yeah. Now the Eibishter, Hashem, He revealed to us what He wants us to know in the
Torah.
And everything else, humans are supposed to figure out for themselves. All right. So the Torah you can trust, but what other people tell you, what's revealed to you in the Torah you can trust, but what other people tell you, they learned
Empirically.
Right. And when you learn empirically, you can, or somebody else
told them.
Exactly. But ultimately, whatever's not in the Torah, now different people have different Torahs. Okay, we believe that our Torah tells us the truth. Other people believe some other kind of, they don't call it Torah, but they call it a Bible. Yeah, a Bible or scripture. They believe that their scriptures, their Bibles, tell them the truth. But what doesn't come from the Torah, and even the Torah has to be. Okay, I'm going to write this down.
Interpreted.
Yeah, means there are words, but words can a single word can mean different things, right?
Mm-hmm.
The meaning of words. Guess how you learn the meaning of words?
How?
Empirically.
Mm-hmm.
You learn it from people using the word, and then you're figuring out what they mean from the context of what they're saying. Okay, so words can mean different things to different people. The same word can mean different things to different people, or a word can actually mean two different things depending on the context. Okay, words are they are. I'm going to write this down. No.
Human construction.
That's the word.
Human constructs.
Yeah, human constructs. You know what construction means, right?
Yeah.
Okay.
Build.
To build, yeah. Words are things which humans invent. Humans build it, okay? You understand? So language is what humans build, so you have to be careful. It can mean different things.
So what about that ladder that everyone was trying to build to God,
Mm-hmm.
and then he made 70 different languages.
Right,
So
it was a tower, yeah.
Like one person said, "Give me a hammer," and he gives him a passion tuchis.
Exactly. Yeah, I think and that was the time when people were. Wait, let me finish. Arrogant.
What does that mean?
Okay, arrogant means that they thought they were as smart as God. They said, you know what? God isn't that smart. We're just as smart as God. We're just going to build ourselves a tower, reach up to God, and then we'll be God. And then they found out that they weren't. That's the problem. Okay, now, what we learn empirically, right, is that means by observing, right? Right. Now, when we learn empirically, the only type of knowledge that we have is this type. No.
P probability is B.
Of B.
Of B is A.
No. The probability of B if you observe A.
Mm-hmm.
For example, the probability that this pen will fall if I let go of it. What's that probability?
1.
Okay. Now, can we prove that?
Look, I'm gonna let go of it. I'm gonna let go of it. It didn't fall.
Okay. Now, but most things don't have a probability of 1. For example, what is the probability that tomorrow there will be an earthquake here?
Not a very good probability.
Is it going to be 0?
No.
Okay. Now let's say we go outside and I look up at a tree and I point to a leaf. Okay? What's the probability that that leaf will fall, let's say, in the next year?
A good probability.
Pretty high, but can you say it's 1?
No.
Okay. What's the probability that when you're playing out in the yard, a bird will cock on your head?
Not a very good probability.
But it could happen, right?
That'd be funny.
Right, it can happen.
When it cocks on my head, then it won't be funny, but if it cocks on other people's heads.
Okay, yeah, but sometimes if you look at the windshield, right, you see some
bird cocking.
Yes, right. So it does happen, right? Okay. So what I'm saying is, probabilities, how do we figure out probabilities?
Observing.
Empirically, right. So let's say I have a coin, and I don't think I have a coin, okay?
And you flip it over.
Yeah.
The probability would be a half.
Oh, okay, now wait a second. Let's
The
say we try. Well, let's say we try
Wait,
to.
can I just say
Yeah,
something?
go ahead. Yeah.
Let's say you have a coin, and you flip it.
Yeah.
The probability that it's gonna be heads is 1/2.
Mm-hmm.
The
Okay.
probability that is going to be tails is 1/2.
Okay, so that means the probability that it'll end up on its side and not fall, you're saying that's 0.
Probably, yeah.
Okay.
If it doesn't
Well,
fall,
let's say it falls into some mud. Okay.
If it falls into some mud, the mud will go over it, and then if it falls into some mud,
It couldn't get stuck right on its edge?
If it falls into the mud, this is what will happen.
Yeah.
You'll lose a coin.
That's true. Okay. All right. But let's say you didn't know what the probability of flipping a coin is, and you figure it out empirically. Okay. So let's say we flip a coin. The first time ever that anybody ever flipped a coin, and that person didn't know anything about the probability of flipping coins. Okay. Let's say it comes out heads. Now empirically, what does he have to say?
It's the probability that's gonna fall on heads is 1.
Exactly. So that's it, because we can't prove. Now, human knowledge, okay, human knowledge, with human knowledge, with what humans learn empirically, okay, what humans, and this is a word that you don't know.
I'm guessing.
I'm going to write it down.
Let me see. Self-ascertain.
Right, I didn't even finish writing it. That means figure out for themselves. Ascertain means to figure out. The way people figure out things is empirically. So human knowledge, the human knowledge that people that humans ascertain answers the question of this. Here. Answer the question.
What?
Right. It doesn't answer why, and it doesn't answer how.
What answers the
question of what will happen.
Yeah.
Right? But we don't know why it happens. Why does it happen that way? Because guess who created our universe?
God.
Yeah. Der Eibishter hat beschaffen Welt. And the answer is why? Because that's what he wanted to do. And how did he do it? We're not smart enough to know that. Just like a fly can't figure out how we do certain things, right?
It can't figure out how we get to be giants.
Well,
it can't figure out how.
It can't figure out how we open the door, for example. I bet you it can't figure that out. Although, you know what? Cats are smart enough to figure that out. Yeah, cats can figure that out. So
can Bazzalo.
Right. But what I'm saying is cats also learn empirically, and they learn what happens when you turn that knob. They can figure that out also. So therefore, animals and humans self-ascertain knowledge exactly the same way. They do exactly the same thing. Okay?
Exactly.
Yeah, it's the same. Well, empirically, right? When I'm saying exactly the same thing, I mean empirically, right? That's how they do it. But humans, because they have language, they can reveal things one to the other. All right? Yeah. Now, the amount of things that we know exactly is okay. Let me write that. Let me write this word.
Finite.
Finite. Finite is the antonym. It's the opposite of infinite. You know what infinite means, right?
Going on forever.
Yeah. Finite means it's not forever. Oh, you're right. That's right. And it comes from the word finite and in, which means not. Sometimes in is a Latin root which means not. But sometimes in can actually mean even stronger. You know, it means the opposite of not, even stronger. Okay, but this is infinite. Now there's the word. The human knowledge is. I told you once. I wrote this down for you once.
Infinitesimal.
Right, infinitesimal. Infinitesimal means very, very small, almost zero. Okay, but all the human knowledge that we've accumulated, right, that humans have accumulated from all the thousands of years of civilization, right? Even though it's infinitesimal relative to the infinity of ignorance, right? It's still so large that a single human can't learn it all, right? What a single human can learn is a very, very small fraction of what humans have learned, right? And certainly what humans have learned empirically, you don't have the time to figure it all out yourself, right? And that's why you have teachers. For example, I teach you. Why? Because the things that I learned, that somebody taught me, that I'm teaching you, could have taken hundreds of years for somebody to figure out. Once I tell you, it's very, very simple, right?
Yeah, I don't need to know anything. So I don't need I didn't need to say that. I meant that, like, I don't learn it like this. I learn it like that.
Right. You don't have to learn it empirically. Somebody reveals it to you. Why do you think that you have a violin teacher?
So I can learn how to play the violin.
Yeah, I used
to think that I'm supposed to go like this when I play the violin.
Right. Right. And you're not?
No.
Well,
I'm supposed to go like that.
Oh, okay. Now, what I'm trying to tell you is that's a technique, right?
Yeah, technique.
Right. So your violin teacher teaches you a technique. That technique, somebody figured out just by what's called, I'm going to write the word. It's an expression that we have in English.
Trial and error.
Right. He tried something, he saw that didn't work, then he tried something else.
Didn't work,
and then it could have taken 100 years till somebody figured out, you know what, the best way to do the violin is like you did, or whatever, I don't know how
yes.
Okay, right. Now, would you want to spend 100 years on your own to figure out how to get a nice sound out of a violin?
No.
Is that what you want? Okay, so you understand why we need teachers, right?
But if it took someone 100 years to figure it out, how could he teach it to the next?
Well, he didn't. Somebody was playing the violin and said, you know what, this is better. So he taught everybody do this, and then somebody figured out and said, well, you know what, this way is even better. And then somebody tried something, eventually.
And then they found out that's like this.
Yeah. And sometimes you just learn. Yeah, exactly. Sometimes you try something and it works, and you go, eureka! Oh, this works.
Mm-hmm.
Yeah. So okay. So now, all of these things. Okay. Now, for example, these things that humans, that humans figure out, these human constructs, okay, these human constructs. All right, they're human ideas, okay? Right? A language is a human idea.
Mm-hmm.
God didn't give it to us. It's a human idea. We invent words, right? Because we think that they're useful, right? Or we invent ideas. Now, for example, about 2,000 years ago, and maybe even 1,000 years ago, okay, we didn't write numbers like this. Here, you know what? We didn't write numbers like this. What is this number?
20. There wasn't any. There was no such thing as 0.
Right. And when there was, we wrote 20 like this, and we wrote 25. Do you know how to write 25?
Oh, yeah, 20.
Correct. But do you know how to write 24?
Mm-hmm.
In the way the Romans wrote it. Correct. Now, here's the thing. When you write numbers like this, because you don't know about 0, you see, there's nothing in Roman numbers that has 0. There's no way to show 0. When you write it like this, it makes doing mathematics much, much more difficult. This is called Arabic numerals. When we write 20 like this, it's called Arabic numerals.
These are Roman numerals.
These are Roman numerals.
X, I, Y, I, then this, X, V, I, and on and on.
Right.
And then you get to 100, and you get C, then 1,000, M.
Correct. And I don't think there's much past that. Yes, there is.
There's 500. There's 1,000.
Yeah. Do you know what 500 is?
D.
500 is what?
D.
D. Okay.
And then there's also.
And how about 50?
50 is L.
Okay. Good. All right. Don't waste my paper with all this writing. Okay.
Hey, it comes from my house. It's not yours.
Actually, I brought it from my house, but that's all right. Well, we'll use your house, this paper also. Okay. So when people came up with the Arabic numerals, which actually were invented by Indians.
Why are they called Arabic numerals?
Because the Arabs... Let go. Leave this alone, all right?
But it looks cool. There's something there, but...
Yeah, it's called a watermark.
You
see this thing? It's called a watermark, and I don't know how that's done. But if you look through light, right, you can see it. And I don't know how it's done, but it's done. Okay? Actually, I think you can even feel... No, you can't. Okay, let go. Okay.
Yeah.
When we used when the Indians invented 0, and we used this Arabic numerals,
I know a lot about
it makes...
zero.
Listen. It makes doing mathematics a lot easier, and people could advance. Okay, they could learn more and more mathematics much, much faster. With the Roman numerals, it was very, very difficult to find out new things about mathematics. And once we got the Arabic numerals, the Arabs learned from the Indians.
I have a question.
Yeah.
How do you say 100 decillion in Roman numerals?
I think it's kind of impossible.
Yeah, it doesn't go that high.
Right.
They didn't need that high.
Well, could be. We do need that high because we got
that time.
Well, they could have probably used it because even they had a national debt. Our national debt is $18 trillion.
Well, that's not as.
That's a lot of money.
That's not as much money as 999 decillion, 999 million, 999 octillion, 999 septillion, 999 sextillion, 999 quintillion, 999 quadrillion, 999 trillion, 999 billion, 999 million, 999,999. It's not as big as that one.
But it's less than that 0.99999. Right?
Hey, if you put 0.9999 forever, it would be not 0.9999 forever is the same thing as another one.
Correct. Okay. That's correct. It approaches 1 asymptotically, right? Okay. So, what I'm saying is human concepts, so things that humans invent, okay, to be able to talk to each other and to reveal things to each other, can be very useful. It can help, right? It can help us advance, right? But human concepts can also be very, very bad. Certain human concepts can actually kill people. Okay?
How?
Well, there are certain human concepts, for example, that, for example, say that you should kill other people, because God tells you to do it. That's a human concept, okay, which is that a good human concept?
No.
Okay, so what I'm saying is human concepts can be good or they can be bad, okay?
Well, you want them to be good human concepts.
Well, you can't control it. Humans come up with concepts, and yes, and what these people will say with the bad human concepts, they say, we have a revelation. Our God told us that you should do this and that. You understand? So anyway, when you learn something empirically, when you learn something, okay, when humans learn something, right? Humans learn for themselves empirically, right? But can they prove things? What they learn empirically? Can they? No, they cannot. They cannot prove things, right? It's just taken on belief, right? Sometimes when people calculate this probability that you'll have B if you see A, they make mistakes. They measure incorrectly.
Why?
Because, well, there are actually several reasons. Okay, maybe the instrument we're using is not good. All right, maybe the examples that we're using, the observations we use are not, are not really good. For example, let's say
if I rub this part of this on the paper, then there will be color.
And there is color. It's blue, right?
Yeah, dark blue.
Yeah. Sometimes people, what they observe is what they want to believe. You understand? So if they want to believe something because they think, let's say, God told them something, then they go and they observe something, and they figure out this probability, and somehow they manipulate things or whatever, and it comes out to what their God told them it is. You understand? You understand what I'm saying? Yeah. So now, here's what I want you, something that's very, very important. Okay, to understand.
Now are we gonna do exponents?
We sure will. I'm sorry. I wanted to do this very shortly, not so fast. But I wanted not to drag this out.
Almost 29 minutes.
I am wasting a lot of time. But the thing that okay, then I'll get right into exponents, because I actually was going to review with you all the other stuff that we learned, about negative numbers and multiplying, dividing, and all of that stuff. And how humans figure out these things, But I won't do that now. I'll just tell you this: if somebody tells you that something is true, something that nobody has learned empirically, then should you believe it or shouldn't you?
I shouldn't.
Okay. And if somebody tells you that something happened which nobody has ever seen happen, will you believe it?
No.
Okay, because it has never been empirically, it has never been observed, right?
Mm-hmm.
And let's say somebody tells you that something is going to happen, which nobody has ever seen happen before. Should you believe it? What probability should you give to it?
0.
Okay. So, remember I was telling you about...
But what if it is true?
Huh?
What if it is true?
Well, it could be. But if nobody has ever observed it, what should you say? What's the best thing to say?
I don't believe you.
Okay. So, for example, there are these people that I tell you about, who are very arrogant. They think they're as smart as God, or they think humans are very smart. And they're called...
Humanists.
Yeah. Now, humanists say, for example, that God didn't create life. Life got created all on its own. But nobody has ever seen life get created all on its own. I mean, before there was any life, there was just, let's say there was just a pond of water, right? And there was some stuff floating in the water, certain chemicals or whatever. And they say lightning struck, and it hit that scum in the pond, and that made life. But
how did there be lightning then, though?
Well, lightning. Let's say there was lightning. We get lightning, right? We've seen lightning.
Well, that's because of God.
Yeah.
How do they think lightning was made?
They say it all happened by itself. You say the world wasn't created by God; it was created by itself. Now, has anybody seen a universe that was created all by itself?
No.
Okay, so therefore, so empirically, we don't know that that's true. Correct?
Mm-hmm.
Okay. Empirically, we've never empirically seen that something becomes life out of things that are
animate.
Right. Animate comes from the same word as animal. Animate means living. Inanimate means
not living.
Yeah. Have human beings ever seen stuff that's inanimate just become life?
No.
Right. So therefore,
at least I haven't.
Right. Well, actually, nobody has. And these humans, they actually agree that nobody has ever seen something inanimate come to life. But they say, we know that happened. And in fact, they write books and say that happened, and that was how life began, and then evolution came about, and all of this. And then there are some humanists, they say, we know exactly how the world will end. The world will come to an end, and we know exactly how that'll happen. It'll happen in so many billion years. Has anybody seen the world end?
No.
Okay, so therefore what I'm saying is, if we believe in empirical, if we say that what humans self-ascertain, what they figure out themselves, which doesn't come from God, is empirical, okay, then these people have never seen this empirically, so the best thing to say is the probability of what they're saying is true is
0.
Okay, right, okay.
Now, X. Now,
alright, well, one last thing.
One thing to ask you.
Yeah.
How can we do...
X. I think that's exponents. Alright, I'm just going to say one more thing, okay? And this is very important. This is the last thing I'm going to say, okay? anything that people have observed empirically, okay, and they tell you about, probably only 20% of that is true and 80% is probably not true, even if it's observed empirically. Exactly. For example, for about 50 years, the doctors used to say, if you eat fat, guess what's going to happen to you?
What?
You're going to get fat. They've been saying that for 50 years. And guess what?
It's not true.
Well, now we believe fat doesn't make you fat. You know what makes you fat?
Sugar.
Exactly.
And bread.
Sugar and carbohydrates. So, for 50...
Sugar is carbohydrate.
Correct. Anyway, I think it's correct. I'm not sure. But in any case, what I'm saying is, doctor said, we learned empirically that fat makes you fat. So they observed things, they said something, and now we figure out that it's not true. But we may figure out that it is true. Maybe 50 years from now we'll say, yes, it is true.
Wait 1 sec.
Yeah.
Let's tell you something.
So what I'm saying is what you have to be is a very important word here, which is what I am.
Skeptical.
Skeptical. You know what skeptical means?
No.
Oh, you don't know? Okay. Skeptical means you say, hey, I'm not sure that I believe you. Now, here's the problem about, even if 20% were true and 80% of what we learn empirically is not true, that could be very useful, except that there's no way to know which of the 20% is true, because there's no way for us to prove anything, correct? You understand what I'm saying?
Yeah.
All right. So we have to be skeptical, right?
So if you cross out the truths, then you'll have just 80% not and 20%.
Right. So you know what the Torah tells us?
What?
Only trust der Eibishter. Only trust the Torah. You trust only God, and the way God tells us is through the Torah. Okay. Exactly. Don't trust the human.
No, but what if it's true?
And you know what?
Sometimes trust humans.
Well, you know what? Of course you have to trust humans. You trust me when I teach you math, right?
Yeah.
You trust your violin coach, right, when he teaches you? Because over many, many hundreds of years, right, people figured things out and improved things. But sometimes there are certain things that people believe, or they want to believe, okay, because they want to do things that are, for example, against the Torah or whatever, okay. And so you can't trust everything that people say. Understand? A lot of stuff turns out to be actually could turn out to be actually very bad for you. You know, for example, if you eat certain bad foods or something, you can get unhealthy, right?
Mm-hmm.
Okay. All right. So now let's.
What if you eat poison?
I think that, by definition, is not good.
Like, hey, what if you eat drink? If someone else says, I want H2O, and you say, I want H2O too. What if they give you poison? Will you drink or not?
Well, you know what?
Uh-huh.
There's actually some guy, and remember I told you this, because we cannot prove anything and we only learn empirically, and most of what we learn has to be revealed, that some very bad things, can happen. We have to, we trust we are very uncertain about what we know, right? You understand what I'm saying?
Yeah.
We're very uncertain about.
Now can we do?
Yeah. Okay. I'm just going to tell you something. Okay. There was a guy. His name was something Jones. I forget what it was.
Skippy John?
No. He convinced a lot of people that God spoke to him, and everything he said was directly from God. And he told these people, one day he told these people, and there were hundreds of them, God wants you to drink poison. He put poison in, you know what Kool-Aid is?
No.
Oh, it's some kind of a drink. But anyway,
Huh?
he put poison in Kool-Aid, and he told all the people that believed that God was talking to him to drink Kool-Aid, and they all killed themselves. Okay, so that's the problem about that our knowledge is either empirical or revealed, and even empirical knowledge that humans learned empirically, even that we can't learn it all ourselves. Okay, so that's why you have to be very,
that is not fair.
Right.
God didn't tell him that
Of course not. Does
he know that God didn't tell him?
Well, he was crazy. He thought that, Anyway, okay. Now let's do exponents, okay? Now I want you to come up with a rule. I'm going to write. Oh, you want to show me something? Go ahead, show me something, and then I'm going to show you something.
How do you draw the infinity sign?
Oh, an infinity sign is a sideways 8.
Okay.
An 8 on its side.
Okay, so.
X times Y times Z equals infinity?
That's what Aaron said that his dad told him.
Well, I think Aaron's dad was making a joke with him.
Maybe. Or maybe that's not what he said. I forget. But
Okay.
it has X, Y, and Z and infinity in it.
I don't know. Okay. All right. Now I'm going to give you some examples, and I'm going to want you from those examples. I want you to do something, and what I want you to do is this.
Generalize.
That's not what I wrote.
Induce.
Correct.
Or whatever.
All right.
I thought that you meant generalize.
Okay. Let's do.
What does induce mean again?
Generalize.
Oh.
To make a rule, right?
Yeah.
To say what
I said
from a bunch.
generalize.
Yeah, right. Remember, there's 3 ways to learn.
Oh yeah. Induct.
There's 3 things. Induction. That's generalization, right?
And there's also deduction.
Right.
And there's also
Which means what? What does a deduction mean?
proof.
Right.
And
can we prove without making right? Without making assumption?
No.
Right. Right. An abduction is an interpretation.
Now let's do
Okay, I'm doing exponents now. Okay, so I'm going to give you some examples. Okay, and you tell me from the example. You're going to give me the answer to something. Okay. Okay, and I'm going to do this. X to the 5th power divided by x to the 3rd power equals what?
Wasn't there something that we can do to make it easier?
Well, you have to understand what x to the 5th power means and what x to the 3rd.
X times x times x times x. Oh, I know. The answer is x squared.
Very good. Okay. Now, I'm going to give you another example. 5 to the 10th power divided by 5 to the 7th power is equal to. Correct. Read it so that we can see here.
Is equal to 5 to the third power.
Okay. Very good. And by the way, 5 to the third power happens to be... Right. Okay. Now, y to the second power divided by y equals...
It equals... y...
Correct. It equals y, and you can also write y as y to...
the first power.
Right.
And this should be... That will make it easier.
Okay, very good.
I know the rule.
Okay, so...
Can I write the rule?
You write the rule. No, I'm going to write something and then you write the answer. Or you want to write the whole rule yourself?
X to the y power, let's say.
Well, I want to do x to the m power.
Okay. X to the m power divided by x to the n power equals x to the m minus n power.
Correct. Correct. X to the m minus n power. You've induced. Can we prove that?
No.
No, but we just say that's correct. Yes?
Mm-hmm.
All right. So now, having done that, and I'm glad that you put the parentheses around x minus n, so you know that first you take x minus n and you take it to that power, right? You take the x to that power. Okay, so let's say m equals 3 and n equals 3. Then what do you have?
X.
Write it down. Write it down. Substitute in here.
X to the third power divided by x to the third power equals x. 1. Hey, that was equal 1.
Wait a second. Use this rule here.
3 minus 3 is 0, so that will be x.
No.
Oh, it would be 1.
Right. But what will it also be? Use this rule. Use your own rule.
X to the 0th power.
And that's equal to?
Equals 1. So it was 1.
Remember I kept telling you that any number to the 0 power is 1?
I used that for when I was practicing. I used that anything to the 0th power is 1.
And now do you see why?
Yeah.
Okay. Now you see. Okay. We don't really. Okay. In any case, what I'm saying is we've induced, and now you can see that x to the 0 power is 1, right?
Mm-hmm.
Okay. Now now let me do the following. M equals 2. N equals 5.
Ooh.
Now use this. Use this.
X to the negative 3 power.
Right. But
what's x to the
but now let's actually write it out, okay? X to the second power divided by x to the n is
5.
Okay, and you know what this is? If you write it out, if I write x, I'm going to show you this
times
way.
X, and then x times x times x times x times x. You could just cross this out with that and cross this out with this, and
then equals. So what do you get?
X to the third power. X to the negative 3 power.
Yeah, but wait a second. Up here you get
0.
No, you don't.
You get 1.
You know that, right?
Yeah. Yeah.
And down here you get
3.
x times x times x And that you can write as 1 divided by x.
To the third power.
So x, 1 over x to the third power, 1 over x to the third power is equal to, correct?
Yeah.
You understand that?
Mm.
Right?
Mm.
Yes?
Yeah.
Okay. So now you learned from generalization. You learned that dividing by x cubed is like multiplying by x to the minus 3.
Mm-hmm.
Okay?
Mm-hmm.
That x to the minus 3 is the inverse of 1 over x cubed.
Mm-hmm.
Right?
Yeah.
Okay. So, okay, let's now. Let me ask you something. X to the m, the whole thing to the n power is the same as what? Just a period. You don't put an x here between the m and the n because that's confusing.
Oh yeah.
Okay, write it over again. You don't even need the period. Mn means m times n. Okay. From now on, right, exactly. So let me write it. X to the m, the whole thing to the n power, right, is x to the mn. All right.
Yep.
Now, what is x? Now I'm going to do it differently. To the n power, the whole thing to the m power. That's equal to what?
Isn't it equal to the same thing?
Correct. And m, yeah, right.
To x to the m n.
Right.
Equal to the x to the m whole thing to the n.
Correct. Right. So it doesn't matter, right? It doesn't matter what order, in what order you do the exponents, right?
Mm-hmm.
All right. So now, using this fact, right? Let's take the following, all right? X to the 1/3, the whole thing to the third power, is equal to what? X to the 1/3, the whole thing to the third power.
Can I multiply fractions?
Why not?
Okay.
Okay. Well, let's put it this way. We're okay, right. Here's what I'm saying. Okay, that's a very good point. Here's what I'm saying. You remembered this rule, right? X to the n to the m.
Wait, that would mean x to the third to the 1/3 to the third is the same thing as x.
Correct. Right. That is the same thing as x, right? If that's the same thing as x, this thing is what you're cubing to get x. So if this is the thing, you see, you're cubing whatever is here, right? Let's call x to the 1/3 power. Let's call it y. If y cubed equals x, then y must be equal to the third root of x. Correct? You understand?
Yeah.
So therefore, x to the 1/3 means the third root of x. You understand why?
Yeah. And watch this.
Okay.
The square root of 4 times 4 plus 2 cubed plus 10 cubed
Right.
is equal.
Yeah. 32. Well, okay. I'll believe you.
Because 4 times 4 is 16, plus 2 cubed is 8, 16 plus 8 is 24, plus 10 cubed, which is 1,024, and I did 32 divided by 32 times 32 before, and I got 1,024.
Very good. Okay. Now, let's go on. And I'm teaching you.
I know something.
Yeah, go ahead. Go ahead. Go ahead. Okay.
First root of that equals.
The same thing, right.
There.
Okay.
Oh, I forgot to write the equal sign.
Okay. Now, let's see. What is okay, now, what is, I'm going to ask you a tough one now. Let's see if you can figure it out. And I'm, okay, now you're going to have to use your brain. X to the 6th power, okay? Y, let's say y equals x to the 6th power. And now I want the square root of y. The second root of y, the square root of y is equal to what?
The square root of y.
Yeah, is equal to what?
Okay, the square root of x squared.
The square root of what? Y
X
is what?
to the 6th.
The square root of x to the 6th. What do you think that is? Correct. You were hesitant. You were scared, weren't you? I could see you were scared. It is x cubed. Because to take the square root is to take the square root of y, right? Look, when I do the square root of y, right? We say that that's y to the 1/2 power, correct? Remember?
Yeah.
Right? 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 We say that? But what is y? Y is x to the 6th. So it's x to the 6th, the whole thing to the
1/2. And then you do, which equals x to the 6 times 1/2.
right.
Which equals x cubed.
Very good. Very good. So what I'm trying to tell you is that once we come up with this rule here, once we come up with this rule that
I made it up. Oh,
well, no,
someone else made it up before me.
Right. Well, you know what?
I thought of it.
Yeah, but you see this x to the m to the n, this whole idea of exponents, that is something. And I'm going to point to the word. It's a
human construct.
It's a human construct. Humans invented it, but these human constructs are very useful. Okay. So in other words, this human construct of exponents, is that a very useful thing?
Mm-hmm. You don't have to, like, let's say you're trying to write
X times, yeah, go
X
ahead.
to 1 trillion. Instead,
you mean X times X times X times X a trillion times, right?
Yeah, instead of having to write
X a trillion times, right?
Yeah, or let's, instead of having to write
Right. Okay, I understand.
instead you can just write and be done.
No.
Is it x to the 12th?
No. We're not yet. A trillion is 10 to the 12th, right?
Oh, I meant 12, 10 to the 12th, not...
Oh, 10 to the 12.
to the-
Okay. Yeah, but suppose you wanted to write. Suppose you wanted to write 10 to the trillion power. Okay. In other words, let's do 10 to the trillion power. This is to the million, to the billion, to the trillion power. If you had to write that out, you would have to write. You die before you'd write it out, correct?
Yeah.
So this is a human construct, which is very good, but you have to understand, humans invented it, right? It's a human construct. And human constructs can be very useful, or they can be very, very bad. They could be very deadly. You understand? Right. When people, when people think that they're God, they can come up with human constructs that can be very, very bad for human beings. You understand? Okay. So, but look, you understood. Let's write down what you understood, so we go over this. Okay. You understood that x to the m to the n power, right, is equal to the x to the m times n power, right? And then we said, you know what? Let's apply the same rule even if m and n are fractions. Right? Even if they are fractions, and let's see what it means. And that's how we found out that x to the 1/3 means the cube root of x. And you understand why, because x to the 1/3 to the third power is x, right? Do you understand that? Yes?
Yeah.
Okay.
What's this?
So here's what we did, Salman, and this is very important, okay? What we did was we came up with a human construct, which are exponents, and then we came up with a rule that x to the m n, with x to the m to the n, where m and n are integers, is this. But then we said, you know what? Let's just say we want the same rule to be true with fractions. What does that mean? And now we understand what it means, right?
Yeah,
it means
also,
taking the root of something.
And also this, where was it? Where did I do it?
Right.
Right over the.
Oh, here. X to the minus n is equal to what? Write it another way. Let's see if you can think. Write it up. No, it's not equal to that. X to the 1/n is the nth root of x. X to the minus n is what?
The negative n.
X to the negative n is what? Well, let's go back, because I guess you forgot.
Wait.
Here, hold on. Here,
Wait.
we had it here. Remember here. You came up with the rule x to the m divided by x to the n.
There isn't any division here.
No, I'm just saying. Okay. This is a special case of this. How can you get from here to here?
X to the
X to the minus n. Look here. I'm going here. X to the minus n. How do I get from x to the m minus n? Right. How do I get how is that equal to x to the minus n? How can that be?
You took away the m.
What do you mean you took away the m?
You subtracted. Let me see. You did m and minus m. M.
Yeah.
And minus m.
What do you do? What is m?
M is I don't know what M is.
What does m have to be so that m minus n is equal to minus n?
0 then.
Okay. That's why I'm asking you to think, right? Right?
Yeah, but I didn't think that you were asking me to do that.
Right, that's what I meant, okay? Right. So now look, x minus n. So to get to this, what has to be? If m is equal to if m is equal to x to the m minus n is equal to x to the minus n if m equals
0.
0. So but x to the m minus n is the same as x to the m
divided by n.
x to the n. So now
X to the 0th power is 1, so it's 1 over x. And that was what I was trying to say.
so therefore x to the minus n equals
That's
1
what I was
over
trying to
x
say.
to the n. Right?
Yeah, that was what I was trying to say. but
That's what you were trying to say, but that's not what you wrote, did you? Okay, well now you're learning this thing, okay? Right? You're learning it?
Yeah.
Well, what time is it? What's it say?
What time?
No, no, it's right here. 3:32. Okay. Don't do this. Don't screw it up.
I'm not going to screw it up.
Okay, all right. Okay, look. Okay, look. I did something very. I skipped something, and that's why you had a difficulty. Okay, look here. Let me write it over here, and just pay a little bit of attention. Remember, we came with x to the m divided by x to the n is equal to x to the m minus n, right?
Yeah.
Now, the problem is, I'm saying now, suppose n is bigger than m, right? Then what you have to do is you have to do something we learned earlier, right? Okay, let's make m equal to. Let's make m equal to 4 and n equal to 6, okay? Then you have x to the 4th divided by x to the 6th, and you know that that's
X to the 4 minus 6, but that would be equal to x to the negative 2,
correct.
and which is equal to the square
No, it isn't.
root of x.
No, it isn't.
It isn't?
No. You can tell. Look here. Write out x to the 4th and write out x to the 6th. What will it be?
Let me show you. X to the 4th is x times x times x times x. X to the 6th and that would go boom, 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 boom. We have 2 left down here, right?
Yeah.
And 0 left down here, so that's negative 2.
Oh, wait, okay, but what is that? Look, if you have 5 times 5, we're getting confused, times 5 times 5 divided by 5 times 5 times 5 times 5 times 5 times 5, what is that?
First you can cross out that, and that, and that, and that, so it will be negative 25.
No.
It will be 25.
No. What is 5 divided by 5? What is that?
1.
You cross out the 5's.
0.
What is 5 divided by 5?
1.
What is
What do you think of
5 divided by 5 times 5? By 5 times 5.
5.
5 divided by 25 is 5?
5 divided by 25 is 1/5.
So how did you get 5?
I don't know.
Okay, because you got confused with the crossing out, right? Right? You got confused with crossing out. Look. Okay. Yeah. Look, next time I'm going to spend a lot more time on the math part. Okay, we'll get you going. Look. 5 divided by 25 is
5 divided by 25. Okay, you can divide that by 5 over 5. So you're basically dividing it by 1. And then this equals to 1, and this will equal 5, so 1/5.
1/5, right.
So this that you want me to say, where was it? A.
Yeah.
This? No.
Over here.
This.
Yeah, this one.
Over here, this will
X to the 4th divided by x to the 6th.
X times x times x times. It will be x 2 divided by x. No.
Okay.
I don't know.
Okay.
This is just confusing me.
Yeah, I know. But what you don't realize is what you don't realize is that okay, let's do it this way. I'll show you this way. Okay, x times x times x times x divided by x times x times x times x. I'm really probably confusing you. Times x. Okay. Okay. When you're crossing out, when you divide x by x, what do you get?
1.
1. So when you cross this out, you have 1. When you cross this x by x, you get times 1, right? By x by x, you have 1, right? X, you get 1. And now you're still dividing by another x and another x, right? So
1 divided by x times x.
Right.
That's what I was trying to say.
But you were trying, but you didn't say that, right? But that's what you were trying to say, right? You understand? Yeah. Right? Okay. Okay. Yeah. All right. Yeah. Okay. You understand? So that's the point. All right. That's the point. All right. You know what? We're gonna sort of quit now.
Why?
Because I think it's getting time. You know, I have to. If I don't go home pretty soon, I'm gonna miss. It's gonna be very difficult. I'm not gonna get home before Shabbos.
What? But then you can stay for Shabbos, and anyway, you're coming tomorrow night back.
I know, but then Bubby is gonna be by herself.
Okay.
Right? Yeah.
And you're by yourself 2 days a week.
I know, but I don't want to be away from her now. Also, right? Do I want to be away
You're
from
not
her?
alone. You're with me.
That's true. Okay, listen. I did manage to confuse you.
Okay.
And I apologize that I managed.
Should I do stop recording?
Yeah, stop record. Wait a second. Before you stop recording, I'm going to take a couple more minutes, okay? A couple more minutes. Like 2 times 3 divided by 3 times 5, okay?
You can cross these out.
Right.
That's 1.
Right.
So that's 1 times this side and 1 times that side.
It's just 2/5 is what it is.
2/5.
Right. In other words, if I write 2 times 3, here's the thing that you have to and you can you can verify this empirically. It's the same as 3 divided by 3 times 2 divided by 5.
Then that would it be equal to 6/15?
Right, and that's the same as 2/5. You see?
So you can divide both by 3.
Yeah.
And that would make 2 on this side, and 15 divided by 3.
15 divided, no, not by 2. By 3, yeah.
That's what it says.
Yeah, exactly. Look. So if you have x to the 4th divided by x to the 6th, right? You can think of it this way. Divide x to the 4th by x to the 4th, you get what?
You'll get 1.
You divide x to the 6th by x to the 4th, you get? X to the 6th divided by x to the 4th, you get?
X to the 2nd.
Right. But using this rule that we had, it's
can I read your mind?
Yeah.
Think of a number.
No, it's just the last thing. It's x to the -2. Do you understand?
But can I just read your mind?
Okay.
Think of a number.
Yeah.
2 times the number.
Okay.
Add 6.
Okay.
Divide it by 2.
Okay.
Okay. Now, take away the number that you started with.
Yeah.
You have 3.
Yes. Okay. All right. So yeah. We're going to have to spend more time getting this. It's a little bit difficult, but it's a little confusing between x to the mn and x to the m times x to the n.
Ready?
Okay. All righty. Zalman, yeah, that's it.